Hi, welcome back to Moose and Chemistry. This is Colligative Properties Lesson 1. Okay, we're going to be looking at a couple things in colligative properties. Remember that the freezing point of pressure is delta TF equals IKFM, and the boiling point elevation is delta TB IKBM. Van Hoff factor is I, and remember that molality is moles of solute over mass of solvent in kilograms. All right. So let's go ahead and let's get started here, okay? So it says, determine the boiling point elevation of H2O for the following. 2.5 molal solution of C6H12O6 and water. Okay, so let's see here. We're doing the boiling point elevation. So let's go ahead and write that. Delta TB equals I KBM. All right, so let's go ahead and write out our factors here. Delta TB I KB and little m. All right, so the Van Hoff factor I, unless we're dealing with a metal, we don't have to really worry about the ions, so it's always going to be 1. Our boiling point elevation is what we're looking for at delta TB. Our KB for water for the boiling point is 0.51, and that will be degree C over molal. And our molal value was 2.5 m. So now all we have to do is isolate for delta TB, which we've already got in this straight equation. So this will be delta TB equals Van Hoff factor of 1 times our KB, which is 0.51 degree C over M, times our molal, which is 2.5 M. M's cancel out, and our delta TB value is going to be 1.3 degrees C. That's going to be the boiling point elevation. All right, so let's look at the next problem here, guys. Okay. Now, when we look at the next problem, it says that a solution of 10.3 grams of glucose, which is C6O3 H12O6 and 250 grams of water. What is the freezing point depression? Okay, well, now when we look at that, first thing we got to look at is we got to look at the fact that we're dealing with grams. Okay, so when we're dealing with grams, we're going to have to change that into molal, right? So we have to change grams first into moles, and to do that, we're going to have to take the following. Hang on for 1 second. Okay, so we're going to take, and we need the formula mass for C6H12O6. Right, so we need to calculate that first. Okay, here we go. All right, so let's get that done first. C6H12O6. So this will be 12.01. This would be 1.01. And this would be 16.00. And when we do the math on that, that's going to give me approximately 180.18 grams per mole of C6H12O6. All right, so that's been established. Also notice that we have 250 grams of water. So we have to put that into kilograms because remember, molal deals with kilograms, right? So we take 250 grams and turn it into kilograms, and we get the 250 here. Move the decimal 3 points over. It'll be 0.250 kilograms. All right. So we're going to go and figure things out here. So let's see here. We're going to take 10.3 grams of C6H12O6 times 1 mole of C6H12O6 divided by the 180.18 grams of C6H12O6. So when we do that, that's going to give us a mass unit of 0.057. 0.057 moles of C6H12O6. And now I have to calculate molality before I can use the delta TF formula. So we're going to go little m equals 0.057 divided by 0.250. So little m is going to equal, let's see here, 0.228 little m. All right, now I'm ready. So I go delta TF equals IKFM. Well, the Van Hoff factor I is going to be 1. So delta TF, because this is not an ionic compound, so this is going to be 1 times the freezing point depression, should be, so here, negative, because it's negative 1.86. 1 second. Yes, it's negative 1.86. 3C over M times 0.228 M. Our M's cancel, and our freezing point depression is going to equal, let's see here, approximately, let's see, let me get this one thing going on here. Ow, let me get my calculator. So we got negative 1.86 times 0.228, and that's going to give me negative 0.42. degrees C. Well, guys, that's it for this lesson. You be snarly, and we'll see you back here at Musin Chemistry.